8.3 Linear Programming. This session now talks about some practical situation, okay, and how to consider the situation with all the conditions and think it as a linear programming. 線性規劃. Here we have some constraints in Chinese 約束條件. And after consider the constraints, we need to find the feasible solution. 可行嘅解 OK 呢度用少少講解一下 Linear Programming 咧，其實係去考慮好多唔同嘅條件底下，我哋點樣揾一個解決嘅方案 OK 咁喺唔同嘅情況底下，例如喺二次大戰嘅時候咧，其實係會用到呢一樣嘢去解決軍事上嘅問題，例如喺有限嘅日期、時間同埋糧食底下，我點樣可以盡可能解決當其時嘅問題？呢個係一個好簡單嘅介紹。Okay, now have a look. 8.3a. Consider this situation. A carpenter is going to produce X tables, and Y chairs. Okay? And the details of producing a table and a chair are as follows. For a table, for a chair, do you understand this table means? Yeah, wood required, working hours. When you make a table, when you produce a table, you need to use 6 units of the wood with 2 working hours. For one chair, you need to use 2 units of wood and 1 hour to do it. Now, given that a carpenter only has 30 units of wood and 14 working hours. Okay? So, how can we do this one? Write down all the constraints about X and Y. Okay? And B, represent the feasible solution on a rectangular coordinate plane. Write down all the constraints. Actually, this is the step 1 when you do the linear programming. And this one, steps 2. After write down all the constraints, then we need to draw on the rectangular coordinate plane. Okay, let's see. What are the constraints? Think about the woods and the working hour. Here we have, okay, if one table, then 6 wood. If one chair, then 2 woods. Now we have X tables, right, and Y chairs. Then, how many woods should we use? Yeah, 6 X woods for produce X table, and 2 Y of the woods to produce all chairs, Y chairs. And we only have 30 woods, so not greater than, okay, that means smaller or equals to 30. Can we use up all 30? Yes, so including the equal sign. This is the first inequalities. How about the second one? About the working hours. Yeah, 14 working hours. And now 2x for making table, 1y for making chairs, okay, and not greater than 14 hours. You only have 14 hours, right? Any more? Okay, the last constraint I think you need to memorize. Sometimes we use X and Y representing the thing. One is table, one is chair. So any condition for X and Y. Yeah. X and Y are non-negative integers. Okay? Remember, if xy becomes a decimal, actually it's not the solution. X and y must be the positive integers, or say that non-negative, because you can x and y can be 0. Okay, that means only make tables or only make chairs, whatever. So better to write like this: x and y are non-negative integers. Okay, this one is the answer ready. Maybe if you would like to simplify, you can simplify like this. That means 3x plus y smaller or equals 15. Okay, second one, 2x plus y smaller or equals 14. The last one, you still keep it. Okay, understand? This is part A. Okay, part B. Represent the feasible solution on a rectangular coordinate plane. Okay, so how to represent this one? So each time, remember, we need to consider the straight line. One is here now is 3x plus y equals 15 x y. Then any values. And the other one you need to consider is this 2x plus y equals 14. Okay, so for the first one, 3x plus y equals 15, what should we choose? Remember, I told you already, when x equals 0, what is y? When y is 0, what is x? Is a good choice. When x equals 0, y is 15. When y is 0, x is 5. Okay, maybe consider one more point. How about if x is 3? Y is 6, correct. Good. How about the second straight line? 2x plus y equals 14. So 2x plus y equals 14. If I still use like this, x equals 0, then y is 14. Y equals 0, then x is 7. Good. Then any other points? How about we consider when x equals 4, y equals 6, correct. Okay, so afterward, draw the straight lines. And here we have how many constraints actually? You can say that 1, 2, and how about this one? Actually, this one, the concept is x greater than or equals 0, y greater than or equals 0. Okay, that means you have 4. This is the third one, this is the fourth one. Okay, x greater than or equals 0, y greater than or equals 0 is the easiest one. So write down this one. This one is x equals 0. How about this one? Y equals 0. Yeah, these two are the simplest one. Okay, easiest one. Next, 3x plus y equals 15. 3x plus y equals 15. Mark it. Okay, no scale here, cannot. Okay, -1. Okay, 1, 2, 3, 4, 5, 6, 7, and 8. How about vertically? Just like this. So you need to mark all the points here on the axis, both axes actually. Okay, so consider the points x equals 0, y equals 15. That means here. Okay, here x equals 5, y equals 0. That means here. Okay, one more point, 3, 6. 3 and then 6 here. So at the end, let's see. passes through this few points. Not really good. Okay, let me see. Maybe I draw it like this. Oh, sorry, once again. Yeah, it's better, right? Maybe right back here. Yeah, just now this one is better. Okay, this is the straight line 3x plus y equals 15. Remember all the straight line with the equal sign. Okay, equal sign. Next, 2x plus y equals 14. 2x plus y equals 14. So one point is 0, 14. One point is 7, 0. And 4, 6. 4, 6. Okay. So now let's draw the points here. Okay. Good. This one, 2x plus y equals 14. Both smaller than 0 and positive y here. So lower half plane. That means we need to draw it like this. Okay. And this. This one and this one. Okay. So which part are the feasible solution? Think about 1, the upper part, 2, right hand side, 3 and 4, both lower half plane. That means here we just consider this part. Okay, understand? Yeah, that's great. Is it a feasible solution? Yeah, remember x and y are non-negative integers, so not all the points in the shaded region. Then what are the solutions? You can mark it like this if you have time. For example, the integral values in the shaded region. Okay, the integral value of the shaded region. So you can mark it like this. Okay, for each point. This time it's quite easy for you to mark all the points in this shaded region. However, sometimes you found that cannot mark all the points because sometimes not 15 or 5 is 100 or 200. So sometimes you need to write down the sentence. I told you before, do you remember? Last few questions. Okay, now I write it down for you once again. You can write it as, okay, the points or the ordered pair, okay, representing all points with integral values. Integral value, that means integer points, okay? Integral coordinates here. In the shaded region, represent all feasible solutions. Okay, so it's better for you to write down this sentence than you just shake the region is enough. No need to point out all the points. Otherwise, you can point by yourself. Okay, mark all the points by yourself also. Okay, so have a look once again. Find out all the constraints according to the question with certain condition. Okay, then draw the straight line. Okay, and remember whether x and y have the condition or not. This time non-negative integers. Afterward, draw the straight line. Consider the correct lower half or upper half plane, left or right, top or bottom. Then shake the regions. And according to x and y conditions, sometimes you need to write down is the integral coordinates only are the feasible solutions. Understand?